Hello and welcome to this screencast on determinants. So here I'm going to show you how to calculate the determinant of a 2 by 2 and a 3 by 3 matrix. So I'm just going to start off by defining or showing you what the notation is for a determinant. So here we have a 2 by 2 matrix, elements A, B, C, D, and we have vertical lines instead of parentheses. So these vertical lines denote the fact we're calculating the determinant. And all a determinant is a numerical value, a single numerical value, which is associated with a square matrix. Okay, so for a 2 by 2 determinant, or the determinant of a 2 by 2 matrix, it's fairly simple. We calculate the product of the elements on the main diagonal. So in this case, I have A and D. So I multiply these two together, and from that, I subtract the product of the other two elements. Okay, so here the other two elements are B and C. So the determinant of a 2 by 2 matrix is A times D minus B times C. So it's a fairly simple, quick and easy calculation. So if we just have a look at an example, so this is example 1, just going to make up any matrix, doesn't matter which or what values I use. Okay, so we take the product of the elements on the main diagonal, so in this case it's 1 times 2, and from that we subtract the product of the other two elements. In this case, it's 3 times 4. Okay, so if I just do the arithmetic, 1 times 2 is obviously 2, 3 times 4 is 12. So here I have a determinant which is equal to 10 for this 2 by 2 matrix. Okay, so that's a 2 by 2 matrix, a fairly quick and easy calculation. Things get a bit trickier for a 3 by 3 matrix. Now I'm going to show you two ways in which we can calculate the determinant of a 3 by 3 matrix. So here I have my values, and the first method I'm going to use is called the method of cofactors. So what we do here is we take the top line, the elements in the top line, and for example the first element is A, so I'm going to take A to start with, and I'm going to ignore all the elements in the column A, and I'm interested in this submatrix here, E, F, H and I. Okay, so what we do is we take A and we multiply that by the determinant of the 2 by 2 matrix, E, F, H and I. Okay, so first element on the top row, scrub out that column, and then we calculate the determinant of E, F, H and I, and that's the first bit done. The second bit, if I just change colour here, okay, I take the second element on the top row, in this case B, and I scrub out, or just ignore for a second, the column B, or the elements in the column B, and I'm left with the submatrix D, F, G and I. So the second step is to subtract the second element in the top row by the determinant of the submatrix D, F, G and I. Okay, important thing to remember here is this subtraction. Okay, very common error. So it's first element in the top row multiplied by a determinant minus the second element in the top row multiplied by the determinant. Okay, and finally we take the third element in the top row, which is C in this case. Do the same things, grab out or just ignore the C column, and therefore we're interested in this submatrix here, D, E, G and H. Okay, so this time we add C multiplied by that submatrix D, E, G and H. Okay, so that's how we calculate the determinant of a 3 by 3. So I'm going to make up an example now just to show you. Okay, just scroll down a bit. Okay, so let's second example for the screencast. Again, making up any numbers. I don't really care which. 4, 5. So it's just a made-up matrix. Okay, so the first step, just use consistent colours. So I have 1. Okay, so element 1, scrub out that column, and I'm interested in the determinant of that 2 by 2 matrix. So 0, 4, minus 2 and 5. Okay. And the next step, we take the second element, and remember we're subtracting. Okay, so minus the second element, which in this case is 3. Okay, so scrub out second column, and I'm interested in that 2 by 2, so 1, 4 3, and 5. So that's the determinant of the 2 by 2 matrix 1, 4, 3, and 5. Okay, and finally the third element in the top row is 2. So do the same thing again. We have 2, scrub out a column for a second, and I'm interested in that submatrix there. So 1, 0, 3, and minus 2. That's plus 2 multiplied by the determinant of 1, 0, 3, and minus 2. Okay, so determinant of this matrix here, 0 times 5 is 0, minus 2 times 4, so that's plus 8. Minus 3 multiplied by 1 times 5 is 5, minus 3 times 4 is 12. And that's plus 2 multiplied by 1 times minus 2, which is minus 2, minus 3 times 0, which is obviously 0. Okay, so 1 times 8 is 8. 5 minus 12 is minus 7, multiplied by minus 3 is plus 21. And 2 times minus 2 is minus 4. Okay, so what do we have here? We have 25. And just checking my arithmetic. Yep. Okay, 8 plus 21 is 29. Minus 4 is 25. Okay, so you can see the determinant of 3 by 3 matrix. Slightly longer calculation than a 2 by 2. But that's one method to do it, the method of cofactors. Just going to have a look at the second method now, which is one called Ceris's rule. Okay, so I'm just going to go back to my general 3 by 3 matrix here of A, B, C, etc. Okay, this is an alternate way of doing this. And what we do here is we form 2 extra columns just to the right of our matrix, and these 2 columns are just repeated the first 2 columns of the matrix here. So in this case it will be A and B, D and E, G and H. Okay, and Ceris's rule is quite a neat little rule. We look at the diagonals. Okay, so I have a diagonal here, A, E, I, B, F, G, and C, D, H. So I find the product of those diagonals, and I subtract the product of the diagonals going in the opposite way. Oops. Okay, so C, E, G, A, F, H, B, D, I. Okay, so you can see we're talking about diagonals here. So diagonals go from top left, bottom right. We add. Diagonals we go from bottom left, top right. We subtract. Okay, so I'll show you how this comes out. Okay, so I'm going to look at the first diagonal, which is A, E, I. Okay, so we've got elements A, E, I. So I'm just going to find the product of those. I add. Just change colours now. Next diagonal is B, F, and G. So add B, F, G. Just another colour, choose green. And the third diagonal is C, D, and H. That's plus C, D, H. Okay, so that's the diagonals going from top left to bottom right. Okay, now I have the diagonals going the other way. So I have C, E, and G. And I subtract the diagonals going the opposite way. So C times E times G. Okay, the next diagonal is A times F times H. That's minus A, F, H. And finally, running out of colours here, I'll choose blue. And we have B, D, and I. Okay, so that's minus B, D, and I. Okay, so that's Ceris's rule. And what I'm going to do now is I'm just going to factorise a bit, just to show you that we get the same answer. So if I factorise A, I have EI, which is this term, minus FH, minus, because I'm going to look at the B's now, B times DI minus FG, and then plus And we've got the C's, so we've got C multiplied by DH minus EG. And if I just scroll up a bit, you can see this is exactly the same as what we got up here. So EI minus FH is multiplied by A, DI minus FG is multiplied by B, and DH multiplied by C. So that gives you exactly the same value for the determinant. So let's have a look at this example showing this. Right, so okay, so this is the third example. Actually, I use the same values of which I did previously, so just got to remember those. So 132 down here, 132 104, and finally 3 minus 2 and 5. So 3 minus 2 and 5. Okay, so using Ceris's rule, I repeat the first two columns. It's 2. Okay. Oops, I don't really need that second vertical line. Okay, so the first diagonal is there. So it's 105. So 1 times 0 times 5 is going to be 0 because I've got a 0 in there. So I'm going to ignore that for a second. Second diagonal is 3, 4 times 3, which is going to be 36. Third diagonal is 2 times 1 times minus 2, which is minus 4. Now I subtract the diagonals going in the other way. So I have 2 times 0 times 3, which is going to be 0. Minus 2 times 4 times 1, which is going to be plus 8, because remember we're subtracting these. So minus 2 times 4 is minus 8, but obviously we're subtracting, so it's plus 8. And finally 5 times 1 times 3, which is 15. So that's minus 15. Okay, so 36 minus 4 is 32. Plus 8. 32 plus 8 is 40, minus 15 is 25. And something's obviously gone wrong there. No, sorry, it hasn't gone wrong yet. So there we can see, up here, we had the value of 25, which was found by the method of cofactors. Down here, using Ceris's rule, we also have the same determinant. Okay, so there you are. That's how you calculate the determinant of a 2 by 2 and a 3 by 3 matrix.